Hi, welcome to Learning Electrical Engineering channel. In this video, we will see series connection of capacitors. For that, we have one circuit which has one voltage source and a number of capacitors connected in series as shown in the diagram. The amount of current flowing through all the capacitors will be same, that is I, and the voltage drop across individual capacitors will be varying. The voltage drop across C1 will be V1 and C2 will be V2 and C3 will be V3, and finally the voltage across nth capacitor will be Vn. Now we need to find out the equivalent capacitance of the circuit to find out the amount of current which is flowing in the circuit. To find out the equivalent capacitance of this circuit, we need to apply the Kirchhoff's voltage law. Kirchhoff's voltage law is stating that the algebraics in a closed loop circuit, the algebraic sum of voltages is equal to 0. In this circuit, we have voltages V1, V2, V3, Vn and V, that is the supply voltage. We are going to apply the Kirchhoff's second law in this circuit. For that, we need to draw a loop like this. And we will mark the arrows like this. As per Kirchhoff's voltage law, as per voltage law, the arrow initially meets the V1 positive potential, so we will write V1 is positive, and we can draw this arrow in either of the direction. The value will be same. For simplification purpose, I have drawn like this, and the arrow initially meets the V1 positive potential, so we will write V1 is positive, and same the arrow next meets the V2 positive potential, so we will write V2 is positive, and so we are applying the arrow method for the voltages up to Vn. The all values will be positive, so V3 plus up to plus Vn, and finally the arrow meets the negative terminal of the supply voltage, so we will write the supply voltage is negative, which is equal to 0. On further simplification of this equation, we will transfer the negative term of supply voltage to the right hand side of this equation. So the equation will become V is equal to V1 plus V2 plus V3 and up to plus Vn. Say this is the equation 1. Now we need to apply the value of voltage in this equation. For that, we know one formula, that is I is equal to C into dV by dt. Now I want the value of only V. So to find out the value of V, we will transfer this dt term to the left hand side of this equation. So the equation will become I into dt is equal to C into dV. So now integrating both sides of this equation, I'll get the value of V. So I'm integrating this equation, I'll get a value V is equal to, C is constant, and we will transfer the value of C to the left hand side of this equation. So this will become 1 by C integral of I into dt. We are going to apply the value of V to the equation 1. So the equation 1 will become now 1 by C. C is the equivalent capacitance value. I don't know the value of equivalent capacitance, so I will write the capacitance value will be as capacitance equivalent, C equivalent integral of I into dt, because the current in series circuit is same. Now this term is equal to V. Same way we will apply the voltage term to individual voltages, that is V1, V2, V3 and up to Vn. So the equation V1 term will become 1 by the V1 is the voltage across C1, so we will write the capacitance value is C1 integral of I is the amount of current flowing through C1, so we will write I into dt. And for V2 the equation will become 1 by C2 integral I into dt. For V3 the equation will become 1 by C3 integral I into dt plus up to the Vn term will become 1 by Cn. This is the nth capacitance value, nth capacitor capacitance value integral of I into dt. So in the above equation, the common term will be I into dt for all the voltage terms V1, V2, V3. So this is the common term. So we will take it out as common. So integral I into dt. So the remaining portion will be 1 by C1 plus 1 by C2 plus 1 by C3 and up to 1 by Cn. And we will write the left hand side of this equation as it is. So it will become 1 by C equivalence integral I into dt. So the equal terms of both side of this equation can be cancelled out. So this we can cancel it out. The equation will now the equation will become 1 by C equivalence is equal to 1 by C1 plus 1 by C2 plus 1 by C3 and up to plus 1 by Cn. Now we can define that the equivalent capacitance of a series connected circuit, series connected capacitor circuit is the reciprocal of sum of individual capacitance value will give the equivalent capacitance of the series connected circuit. The equivalent capacitance of a series connected circuit will be the smaller than the smallest capacitance connected in the series combination. We need to find out the value of current I in the circuit diagram. To find out the value of I in this circuit, we need to replace the individual capacitances to its equivalent capacitance, and the circuit will become like this. The value of current I is flowing in the circuit and the individual capacitors are being replaced with the equivalent capacitance value, and the voltage across the equivalent capacitance will be positive V. The formula to find out the value of current I is equal to C equivalent, that is equivalent capacitance value into dV by dt. So by applying this formula we can easily find out the value of current I in the series circuit. If you like this video, kindly like this video, and if you have not subscribed my channel, kindly subscribe it. If you have any doubts, kindly put it on comment box. I will reply. Thank you so much.